Hey everybody, this is Alex Merced, and welcome to another episode of this Apache Iceberg Crash Course. This is the 8th episode. We'll be talking about versioning with Apache Iceberg. Again, this series brought to you by Gnarly Data Waves and Dremio. So here we go. Again, this is the 8th episode. We're talking about versioning with Apache Iceberg. Specifically, we're talking about catalog versioning, which is something that's currently available with a very particular catalog, and that is available through Nessie. And again, you can learn a lot more detail beyond what we cover here today by getting a copy of Apache Iceberg, the definitive guide. You can scan this QR code and get yourself a copy of Apache Iceberg, the definitive guide. And so that we can read up on all of that. Also, Gnarly Data Waves. Subscribe to Gnarly Data Waves. You can either do that by going to youtube.com/Dremio or heading over to Spotify and iTunes and looking up the Gnarly Data Waves podcast feed and subscribing. And if you have any questions about at any time about stuff that we're covering here, head over to community.dremio.com so you can get hands-on with, ask your questions in the Apache Iceberg topic. And let's begin with our topic. So again, we're specifically talking about catalog versioning. This is specifically a feature of Nessie, which is a open source catalog created by Dremio that they've been, I think it was released in 2020. So it's one of the older open source catalogs. You might have read in a recent Datanami article that a lot of the work that's been put into Nessie will be joining forces with the work that's being done with the open source Polaris catalog. So a lot of the features that right now are currently exist in Nessie might also become part of Polaris in the future. So stay tuned to kind of see how that evolves. But just want to kind of preface that as we go into this. But right now, for this functionality, you would be using Nessie. So if you want to get hands-on with this kind of functionality today, Nessie catalog is the way. So, but first, let's just talk about what versioning is conceptually. Okay, so this is all part of a bigger trend that we like to refer to as data as code, part of a general idea of data ops, of just sort of automating data practices for data quality and things like that. But basically, versioning as a whole, you might have experienced if you've ever written code with Git. Okay, with Git, what you do is every time you make changes to your code, you have a commit. In this case, every time we make changes to our iceberg tables, we have, or a iceberg table in our catalog that creates a commit. And so after several changes, you might create many commits, but then eventually you're gonna be like, I don't want to change the main, what's called the main branch, because that's the branch that is what everybody else sees. So when we're talking about like code, when you're like going on facebook.com, that's theoretically the main branch of the Facebook code base. So you don't want to make changes directly to what everybody else sees, because then what if you break something? So usually what you do is if you're going to add something, you you could create a branch, but also if you have certain checkpoints, certain points in time that you want to come back to, you might create a tag. So maybe this may be for data, this might be like the end of the month tag. So that way we have a very consistently defined end of month point across our entire catalog. Instead of tagging different tables individually across different points in time, we can just say, okay, this point in time, whatever the catalog was like at this point in time, that is the end of month data for that month. Okay. For code, this could be used to tag like particularly stable versions. So you're like, okay, hey, I know this version is pretty stable. Let's just tag this so that we know this release. So each release would probably have its own tag. So that way you can easily go back to the code as it was at that release. But then when you want to make changes, what you can do is you can create a branch, and the branch, what it does, it creates a sort of an alternate path of changes. So you create commits, whether it's changing the data or changing the code. But the thing is that the changes that are here are not visible by people who are operating on the main branch. So potentially people who are changing Facebook's code on a branch I'm not experiencing those changes when I'm going to facebook.com. I'm seeing whatever the most recent commit is from the main branch, the production branch. And then so they can then make changes, and they might have some sort of development deployment where they can see it, so the developers can see it, but not the consumers. And then when it's ready to be released, they can just merge that in and publish that code, facebook.com updates. So in the case of data, this would just mean like the new data now starts showing up in my queries for your consumers. Okay, and so now we can take this paradigm and add that into how we work with data. Okay, now the benefits of versioning is that you get to isolate. So I can isolate work on what, in the same way I isolated work on an application in code, I can isolate work on data So that way those changes don't become immediately visible. So that way I don't have partially unfixed or uncleaned, unprepared code or data showing up to my end users. When you create a branch, it's zero copy. Okay, so a branch can not only just be used for isolating changes, but it could also be used for creating experimental or development environments. So oftentimes nowadays, when you develop something, you create a copy of your existing sort of production environment, which one is expensive because you're duplicating the data so that way you can develop something. But again, things are constantly changing in production. So in that case, very quickly it becomes out of sync and you don't know, hey, does it actually work in production? What you can do is actually work off your production data in an isolated way through a isolated environment, through a branch, and that creates a development environment that's a zero copy, that's essentially working off your production data at minimal cost. Multi-table transactions. Okay, so basically in the case of data, because this is at the catalog level, so we're creating this versioning at the catalog level, the catalog is made up of multiple tables. So in that case, this allows you to do transactions and isolate work across multiple tables and publish those changes at the same time. So you can roll back multiple tables and then publish those changes at the same time. You can add, delete records, multiple tables, whatever you want to do, you can do that in the branch, and none of that becomes visible to your consumers until you publish it back to the main catalog branch. So this creates sort of another layer of versioning on top of the already built-in Iceberg table level versioning, capturing snapshots of the table in the metadata. Rollbacks. So because of Iceberg's time travel, I could roll back a table if I make a mistake and roll back a table to a historical point. But what if you have hundreds of tables? Okay, rolling back hundreds of tables one by one can be a little tedious. With Nessie and with catalog versioning, I can roll back multiple tables. I can just say, hey, let's go back to the last point that I know that the catalog was in good shape, and then I can rerun all those jobs. Reproducibility. Okay, we can reproduce basically through tagging, create sort of specific points in time that allow you to easily reproduce the data as it was. Okay, because you can actually say, okay, hey, this is our end of month, and we can all agree that that's the end of month point that we're all going to base and do our analytics off of, because it has a very clear name. So that way, it's not everyone's like using a different timestamp at the end of the month and having slightly different results when they do historical analysis. And validation, because I can isolate that data, I can go validate it within that branch. So the thing is that the thing to keep in mind is that there are two types of versioning in Iceberg. Okay, there's table level versioning, okay, which I'm not going to get too deep into right now. This is built into the Iceberg spec, but not every tool supports table level versioning, as far as like the ones that work with Apache Iceberg. Okay, because again, at the end of the day, what features they support depend on whether the engine's built that functionality. But what you can do is you can actually build branches within the snapshots within the Iceberg table with simple SQL, and that's fine. But again, it's one table at a time. So essentially, if you want to make changes across multiple tables, you're writing multiple, you're creating multiple transactions across multiple tables that are isolated from each other. There is a way to do multi-table transactions just inherently in Apache Iceberg, but it does require specifically the a catalog that supports REST catalog, and it requires that catalog to have implemented that sort of multi-table, well, really it's more like multi-transaction commits. And sort of like the difference there is like with this sort of level of you have to do it, you're doing all the transactions at the same time. So you're saying you have to define, you're saying, okay, hey, begin transaction. These are the transactions I want to run, end it, and then it'll commit them at the same time. While with catalog version, you can create a branch. You could have that branch open for like a week, do all sorts of stuff throughout that week, and none of it becomes published till the end. But just be aware that there is a table level versioning paradigm that's built into the Iceberg spec, usually meant for like more like temporary branches that kind of self-delete after a while or self-expire. And again, catalog versioning, which is currently, again, exclusively something that exists within Nessie. But again, as I mentioned, the Datanami article later, that functionality may expand over to Polaris catalog, creating basically further solidifying this approach is sort of becoming more and more sort of the standard approach to versioning. Okay, one, because Well, actually, let's just take a look at how it works. Okay, so remember, a catalog is essentially a list of references. And this is what makes Nessie so genius, because what happens is that when they were first creating this versioning system, they tried Git. Okay, the problem is that like when you're using Git, you're monitoring a lot of different objects. You're taking a look at everything in the file system. So, one commit in Iceberg might be adding one file, another commit might be adding thousands of files. So tracking all those individual objects, you're going to have different performance from one commit to the next. But if you do it at the catalog level, the catalog doesn't matter how many files. So basically a change to a table in Iceberg could be 1,000 files, it could be one file, but you're always only getting one more metadata.json, and you're only changing the reference to that one file. So basically, it's no matter how big or small the change to the table is, the update to the catalog is of the sort of the same weight. So you can handle a lot more throughput, a lot more changes could be coming into the catalog at the same time, and Nessie is able to keep up. It's very able to handle high throughput because the way catalogs work are so lightweight to begin with. So essentially, you have here a list of tables, and we'll say their version of the metadata right here. In this case, it would really be like a reference to where that metadata is in the storage system. But we'll say, okay, hey, a change happens. So table B was updated. And notice the commit is essentially another snapshot of the list of references. So we can say, hey, we now know that table B is going forward is now pointing to 2. Okay. And then if I wanted to, just like before, if I wanted to isolate changes, I could create a branch. So basically all my main queries, when they consult the catalog to get pointed to the right metadata.json file, they're still going to hit commit number 2. But here I'm making changes, and table A is now version 2, and table B is now version 3. So they're changing, but those changes don't get published until I do a merge. And now this is what becomes what the main catalog sees. And again, just like Git, I can tag certain commits to become like the end of month commit or something like that to do that. And again, in this case, that tag applies to the catalog commit. So it means this tag applies to all those tables, versus if I was using the table level versioning, I would have to tag each of those tables individually. Okay, so this catalog paradigm makes a lot of things a lot easier because you're doing it across multiple tables that are bundled in our catalog. Now, the benefits, again, of versioning, you get isolation, again, zero copy benefits, zero copy environments, multi-type transactions, rollbacks, reproducibility, and validation, as we mentioned earlier. But specifically, when you're using Nessie, you get that abstraction at the catalog level. Nessie is open source. You do have a managed version of Nessie, which is Dremio's enterprise catalog that's built into Dremio. Okay, that basically gives you all the benefits of Nessie without you having to manage a Nessie server that's just integrated into the Dremio platform. So getting started is just a matter of just opening up Dremio, okay, giving you a really sort of nice integrated experience. Especially like on Dremio Cloud, you literally just open up Dremio Cloud and you don't even realize you're using Nessie. It's just sort of built into the experience. It's cloud agnostic. You can use it like basically catalogs in general. They don't care where the data is stored. So the data could be stored in any cloud. It could be stored on-prem. It doesn't matter, what the storage is. So you can use this across really any environment, which is pretty nice. And basically with Nessie, when you're using Dremio, you do have automated optimization services that help optimize the data across branches, referred to as the GC cleaner. But again, that's just deeply integrated into sort of Dremio's interface. Now, if you want to kind of get hands-on with the versioning and kind of see the power of this in action, I really recommend these two resources. So the resource on the left is a blog post with a hands-on exercise that you can just walk through, and that'll basically, and all of this is done through Docker. So what you'll do is you will ingest data from MongoDB and Postgres into your data lakehouse using this sort of Git-like versioning, and then modeling the data with DBT and delivering a BI dashboard with Apache Superset all in one exercise. Now, if you want to see that whole exercise just played out, just visually without having to do it yourself, you can watch the video on the right, which walks you through that whole exercise, and you can actually just watch it play out right in front of you. It's about 20 minutes long, and allows you to kind of just see sort of how this all looks like in action. So either of these resources would be good to understand that deeper. But also, just getting hands-on with Iceberg in general. Again, this QR code on the left is a good introductory exercise. So if you've never touched Iceberg before, that's a great exercise to get started. Also with just Docker right there on your laptop. And then, if you want to do some more end-to-end exercise, meaning going from ingest all the way to BI dashboard, these 3 exercises right here are also really good exercises that kind of just keep getting hands-on and keep getting used to the workflow. And if you have any questions, make sure to go post them over there at community.drummer.com under the Apache Iceberg topic. But with that, that wraps up this session. I'll see you all later. Have a great day and enjoy.